Here it says a spinner has 10 congruent sectors that have alternating shading and are numbered 1 through 10 as shown below. The pointer is spun. Given that the pointer stops in a shaded sector, so let's count how many shaded sectors we have. 1, 2, 3, 4, 5. So there are 5 shaded sectors. I'm going to take note of that. Probably important. Let's use sectors here. What is the probability that the pointer stops in a sector that is a multiple of 3? So how many sectors that are shaded are multiples of 3? We have this one right here and this one right here. So there are 2 sectors that are multiple of 3 and there are only 5 shaded sectors. So that's how you work through that. So try rectangle EFGH with vertices at -1, 3. So that's E right here, -1, 3, and 2, 3 right here. So let's find the length here. From here to here is -1. So this is going to be 3 units here. And then 2, -1, 2, -1 right here, and -1, -1. So we have 2, -1 right here, and then -1, -1 right here. So we're going to find, we found the width. Let's find the length or the height here. Let's use the length here of the triangle, of the rectangle, sorry. So we have here, at this point, this is going to be 3. This is going to be -1. So this is going to be 4 units. So the area of, because it's asking what percent of the rectangle's area lies in quadrant 4. So what are we really looking for? We're looking for the percent of the rectangle that represents this, that this area represents. So let's go ahead and find the area of the rectangle. So the area is length multiplied by width, which is 3 multiplied by 4, and that is 12. Now we need to find the area of this small rectangle right here in the 4th quadrant. So this is going to be 0 here, from 0 to 3, so that is 3 right here. Oh, no, from 0 to 2 is going to be right here. And then this is from -1 to 0, that is 1. So the area, let's call this uppercase X. So area of X is 2 multiplied by 1, which is equal to 2. So we now have the percent is going to be 2 divided by 12. And this is going to be X over 100. Or you can say multiply by 100. Doesn't matter. So let's make this simpler. 1 over 6. And so 6x equal to 100 divided by 6. We have x equal to 50 over 3, which is going to be 16.67 or something, or 16 2/3, okay? So first of all, I know it's 16, so I'm just going to look for 16, and then the fraction will take care of itself. But if you know the fraction, go for it. If you're not sure, then you can use this method. So here it says, the chocolate mousse lodge sells gift boxes of chocolates. The actual cardboard box is free, and there is a fixed cost for each gourmet chocolate and another fixed cost for each premier chocolate in each gift box. A gift box with 5 gourmet chocolates and 10 premier chocolates costs $30.35. Okay, I already can see that this is a system. So this is 5 gourmet plus 5 premier equal to 30.35. And a gift box with 6 gourmet chocolates and 6 premier chocolates costs $22.68. 6 gourmet. Actually, we have 10 premier in the first one. So let's make sure we're right here. So we have 10 premier. 6 gourmet plus 6 premier is equal to $22.68. Now we're taking, this is the ACT. I know you're allowed to use a calculator, but I always like to simplify equations. So I'm going to divide this whole thing here by 5. and then divide this whole thing here by 6. They are common factors. So we have g plus 2p equal to 6.07, and then we have g plus p equal to 3.78. So let's figure out the cost of a Premier chocolate. So we just subtract. So the Premier is going to be equal to, we subtract right here. This is 9, this is 2, this is 2. So Premier is $2.29. And then Gourmet is going to be subtracting this. So this is going to be $1.49. So now what is the cost of a gift box with 2 Gourmet and 1 Premier? 2 Gourmet, so let's multiply this by 2. So this is going to be 298 plus 229, 725, 527. Next question. In the figure below, K1 and K2 are parallel lines and W and X are points on K1 and K2. In the same plane, point Z lies between K1 and K2 and some angle measures are given. What is the degree measure of XZW? So this right here. So what we're going to do here is we're going to first find this angle right here, because this right here, let's draw a dotted line. This is a common type of ACT question. So once you see this, once you've seen a few of them, you'll kind of get what they're really getting at. So this is 33 degrees here, because this is a straight line and the angles in a straight line. This is a straight angle here. So it's going to be 180. So these are supplementary angles. So this is going to be 33 right here. And this is going to be 37 right here. So Z is going to be the sum of both. So Z is 33 degrees plus 37 degrees, which is 70 degrees right here. Okay, next one. It says a net of a square pyramid with 4 congruent triangular sides is shown below in the standard XY coordinate plane. Points A, B, and C are vertices of the net. Okay, makes sense. What is the total surface area in square coordinate points of the pyramid? Total surface area is going to be the area of every surface. So we have 1, 2, 3, 4, 5 surfaces. So what we're going to do is we're going to find the area of one rectangle, multiply that by 4. Sorry, the area of one triangle, multiply that by 4, 1, and then add it to the area of the square. So let's find the area of the square. That's probably the easiest one to do. So we have from 2 here to 211 to 1211. So the square has a length of 10 units. So side is 10 units. So the area here is going to be 100. So the next thing we're going to do here is try to figure out we're going to find the length here. So let's go ahead and we're using the distance formula. And the distance formula states that between 2 points, the distance between those 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. That's your distance. So we're going to have, so d here is going to be the square root of 12 minus 24, that's negative 12 squared, plus 11 minus 6, 5 squared. So this is going to be square root of, so d here is going to be the square root of 144 plus 25, which is square root of 169, and that is 13. So if this is 13, so here's what we're going to be working with. If this is 13, we're going to draw a dotted line to get our altitude. Remember, area of a rectangle is half base times height. So let's draw the altitude right here. I can already tell you that this is 5. If this is 13, this is going to be 12. We can already see that here. 12, 5, 13. So we have 5 here and also 5 here. So the area of triangle is half base times height, which is 1/2 multiplied by the base is 10, the height is 12. And because we have 4 of them, we're going to multiply this by 4. So this is going to be 240. So therefore, the surface area is going to be 100 plus 240, which is going to be 340. And that's going to be our answer right here.